Hello everyone, I am Pradeep Jha, working as an assistant professor at Arya College of Engineering and Research Center in Department of Computer Science and Engineering. Today, I am discussing the restoring division algorithm, this topic in a subject of 6th semester Computer Architecture and Organization. The definition of division of a two fixed point binary number in sign magnitude representation is done with pen and pencil by a process of successive compare, shift, and subtract operation. Basically, computer architecture has two division methods are used. First, the restoring division method and second, non-restoring division method. First, we are discussing restoring division algorithm. We are use 7 steps in a restoring division algorithm. First step is the register are initialized with corresponding value q equal to dividend, m equal to divisor, a register are used 0 and n number of bit in dividend. The step 2 is used when the content of register A and Q is shifted left if they are a single unit. And step 3, then content of register M is subtract from A and result is stored in A register. Then we are using fourth step, then the most significant bit of the A is checked. If it is 0, the least significant bit of Q is set to 1. Otherwise, if it is 1, then least significant bit of Q is set to 0 and value of register A is restored. That means the value of A before the subtraction with M. Now we are using first step, the value of counter n is decremented. Then step 6, if the value of n becomes 0, we get off the loop, otherwise we repeat from step 2. Now the final step, the register Q contain the quotient and A contain the remainder. Now restoring division flowchart. An n-bit positive divisor is loaded into register M and n-bit positive dividend is loaded into register Q. At the start of the operation, register A is set to 0. After the divisor is completed, the n-bit quotient will be register Q and the remainder will be in the register A. Now, first step are used. First step are uses, then shift left register A and Q. Then after the subtraction of A equal to A minus M. Then check A if leftmost bit of A equal to 1. Then we are we are assigned Q0 equal to 0 and A equal to A plus M. If A leftmost bit is 0, then Q0 assign 1 and then count equal to count minus 1. If count equal to 0, then our algorithm is ended. If count equal to 0, not equal to 0, then algorithm is repeatedly. Then division, restoring division example. For example, let x equal to 00011 and y equal to 0100. Then m equal to x and q equal to y. The 2x complement of x equal to minus m equal to 1101 used in the subtraction. In this algorithm and in this value, we are using 4 cycle. And the first cycle and the first step is initial step. First, we are assigning a equal to 5 times 0 and q equal to, we are given 1 and 000. This step is called initial step. Then apply the first step. The first step is shifted step. Then apply the left shift. Then subtract m and subtract m. Then check a leftmost bit. If a leftmost bit is 1, then Q0 equal to 0 and apply restoring back. Then first cycle is completed and then second cycle is started, and the second cycle first step is using shift left, then subtract m, then check A leftmost bit is 1, then Q0 equal to 0 and restore back. Then second step is completed and the third cycle is started, and third cycle first step is shift left, then subtract m and then check a leftmost bit. If a leftmost bit is 0, then q0 equal to 1, and that time we are not restoring back, and cycle 4 are started. Then cycle 4 first step, shift left, then subtract m and check a leftmost bit. If a leftmost bit is 1, then q0 equal to 0 and the steps are completed. And a storage a reminder and q is a storage a consonant. Thank you very much.